Alright, so welcome back to your favorite Inorganic Tutor YouTube channel. Today we want to look at how to calculate the value or the variance of a particular function x. And the function has been given in the cumulative distribution form, right? But before I begin, let me give a big shout out to Mr. Rad, the man who actually gave me the idea to begin this big initiative, and my own brother Enoch, right, for helping me in all angles to make sure that I elevate this channel to the highest premium. And then the next big ups to Issa Kunal, big ups, big man. All right, so let's look at how we can deal with this particular problem on the board. Said a random variable x has the cumulative distribution function, right? So this is the cumulative distribution function, which is the CDF, all right? And we want to calculate the variance of what? X from this CDF. So first, if you have a function which is in the CDF form and you want to calculate the variance of that particular function, we have to first convert the CDF form into a PDF form, right? So now, how do we do this? Having the CDF form, you know that this is the discrete case and this is the continuous case as well. So now, we know that if x, f of x, f of 1, right? We're going to have 1 squared minus 2 into 1 plus 1 all over 2. And that gives us half, right? So this implies that when x is equal to 1, or the probability of x equals 1 is equal to half, right? So now, since we know this, we can go ahead and then find the PDF, right? The probability density function from the CDF, given the function, right? So here, the probability density function, which is the PDF, right, is the differential of the CDF. So the small f of x is equal to the differential of the big F of x with respect to x, right? So from here, the function given, we know that when you differentiate this 0, it's already 0, right? Then we have to differentiate this function as well, right? So we have the differential of s squared minus 2x plus 2 all over 2 dx, right? So we differentiate this particular function and we have 2x minus 2 all over 2. And this simplifies to x minus 1, right? So when we differentiated the function given, we had x minus 1, right? So now we can go ahead and write or put out the PDF form from the CDF, right? So now the PDF function or the piecewise function from the CDF is going to be, so let's ignore this side first, right? So we have when x is equal to 1, we know that it's half, right? And when we differentiated this function, we had x minus 1, right? Now the range is going to be 1 less than x less than 2, right? And then the final aspect, 0 otherwise, which is not, which indicate that it's a PDF, right? So now, having the PDF piecewise function, we can go ahead and find the variance of this particular function, right? So we know that to find the variance of this particular function, once we have been able to discover or determine the PDF, we can formulate our formula for the variance. All right, can formulate our formula for the variance. And we know that variance of x, right? Variance of x, var of x, so expectation of x squared, expectation of x squared minus expectation of x all squared. Right. So once we have been able to formulate this formula for the variance, we can go ahead and find the expectation of x in the first moment, and then find the expectation of x squared, which is the second moment. All right. So now, expectation of x, we know that this function, the PDS function form, is in two cases. We have the discrete case and we have the continuous case, right? So from here, the discrete case is going to be x times the probability of x equals 1 plus the continuous case, right? The continuous case, which is going to be the x times the function of x, right? So here we have expectation of x equals, we know that when probability of x equals 1, when x equals 1, the probability is what? Half, right? So we have half times 1, right? Plus the range of this function, right? So we have 1 to 2, then x times the function, right? Very, very simple. So from here, we simplify the expression, right? So from here, we know that expectation of x is equal to plus half plus, when we expand this, we're going to have s squared minus x dx, right? So here, from here, from here, we know that expectation of x is going to be half plus the integral of this function is going to be s cubed over 3 minus s squared over 2, right? From 1 to 2, right? So here, we're going to have half plus 2 cubed over 3 minus 2 squared over 2, right? So we have 2 cubed over 3 minus 2 half minus half, right? That is what we have here. So from here, we have half plus 2 cubed, which is 8 over 3 minus 4 over 2 minus 1 over 3 minus half, right? So from here, we can say that the expectation of x is equal to this. When you add up all this, you're going to have 8 over 3 minus 4 over 2. You're going to have 4 over 3 minus minus 1 over 3 minus 1 over 3. Right? So from here, you can say that expectation of x is equal to 4 over 3. Is equal to 4 over 3. So from here, we have been able to discover or find the expectation of x. So since we have been able to find the expectation of x, we can go ahead and find the second moment, right? And that is also equal to x squared times probability of x equals 1 plus the continuous case, right? Here. So we have the second moment 1 times the probability of what? X equals 1 plus 1 to 2 s squared into x minus 1 dx, right? So we have expectation of x squared is equal to half plus integral from 1 to 2. Then we expand this, we are going to have s cubed over 3 minus s squared, right? When we expand this, here's what we have. And then we go ahead and then integrate the continuous case as well. So when we integrate this, we are going to have s power 4 over 4 minus x power 3 over 3 from 1 to 2, right? So from here, we can say that expectation of s squared is equal to half plus 2 power 4 over 4 minus 2 power 3 over 3 minus 1 over 4 minus 1 over 3, right? So we have expectation of x squared is equal to half plus 2 over 2 power 4 over 4, right? Minus 8 over 3 minus 1 over 4 plus 1 over 3, right? So when you simplify this, you add up all these digits, then you are going to have expectation of s squared as 23 over 12, right? So once we have been able to find the expectation of s squared, which is 23 over 12, then we can go ahead and use the formulated formula for variance, right? So the formulated formula for variance of x is equal to the variance, which is the second moment, right? The s squared, expectation of s squared, which is 23 over 12 minus the first moment, right? Which is 4 over 3 all squared. So we have variance of x equals 23 over 12 minus 16 over 9, right? So therefore, we can say that the variance of the function x is equal to 5 over 36, right? So now, we have been able to find the variance of the function given. So we all know that when you have the CDF function and you want to find the variance of that particular CDF function, first you find the PDF out of the CDF. And when you get the PDF, you formulate the piecewise function for the PDF, right? Now, when you have that, you're going to have continuous case and then the discrete case. So when you're finding the expectation, you add the discrete case to the continuous case, and then you find the first moment and the second moment. So that is what basically we have done over here. We have the first moment as 4 over 3 and the second moment as 23 over 12. So when you find the difference is going to be the second moment minus the first moment all squared, right? So we have this as 5 over 36. Very, very simple. Please don't forget to subscribe to the channel, that is Inorganic Tutor on YouTube channel. And I'll feed you with more content on probability, mathematics, especially on calculus, and then statistics and more on economics courses as well. Thank you very much for watching and expect more content as well. Bye.